Have you ever gazed up at the night sky and felt a sense of wonder? The stars seem so far away, yet we yearn to reach out and touch them. What if I told you that humans have already sent objects beyond those twinkling lights? It's true. We've explored the moon, sent probes to distant planets, and even launched telescopes that peer deep into the cosmos. How did we achieve this incredible feat? The answer lies in the power of rockets. Rockets are amazing machines that defy gravity. They carry our dreams and aspirations into the vast expanse of space. From the earliest fireworks to the mighty Saturn V that carried astronauts to the moon, rockets have captured our imaginations and propelled us forward on an extraordinary journey of discovery. In this essay, we'll embark on our own adventure into the world of rocket science. We'll uncover the basic principles that make these powerful machines work. We'll even learn how to build a simple model rocket. Get ready to ignite your curiosity and blast off into the exciting realm of rocketry. To understand how rockets work, we need to grasp a fundamental law of physics, Newton's third law of motion. Sir Isaac Newton, a brilliant scientist, discovered that for every action, there is an equal and opposite reaction. This law is the secret behind a rocket's ability to soar through the air. Imagine yourself standing on a skateboard, holding a heavy basketball. If you throw the basketball forward with force, what happens? You'll roll backward on the skateboard. This is Newton's third law in action. The action of throwing the basketball forward creates an equal and opposite reaction that propels you backward. Rockets work in a similar way. Instead of throwing a basketball, they expel hot gas out of their engines at incredibly high speeds. This expulsion of gas is the action. The reaction is a powerful force that pushes the rocket upward, overcoming the force of gravity. The force that propels a rocket upward is called thrust. Thrust is generated by the rocket's engine. Inside the engine, a controlled explosion takes place. This explosion creates hot, expanding gas. The gas is then channeled through a nozzle, which is a specially shaped opening at the bottom of the rocket. As the hot gas is forced through the nozzle, it accelerates to extremely high speeds. This acceleration creates a powerful force pushing downward. Remember Newton's third law? This downward force creates an equal and opposite force pushing upward on the rocket. This upward force is the thrust that lifts the rocket off the ground. The amount of thrust generated depends on the speed and mass of the gas being expelled. The faster and heavier the gas, the greater the thrust. Rocket scientists carefully design engines and nozzles to maximize thrust and propel rockets to incredible heights. A rocket is more than just an engine. It's a complex system with several essential parts, each playing a vital role in its mission. Let's take a closer look at the anatomy of a rocket propellant system. This system stores and delivers the fuel and oxidizer to the engine. The fuel provides the energy for the explosion, while the oxidizer provides the oxygen needed for combustion. Engine. The engine is the heart of the rocket where the controlled explosion takes place. It mixes the fuel and oxidizer and ignites them to create thrust. Body and fins. The body of the rocket houses the engine, propellant tanks, and payload. The fins provide stability and help guide the rocket's flight path. Payload. This is the cargo that the rocket carries. It could be scientific instruments, satellites, or even humans. These parts work together in perfect harmony to launch a rocket into space. The propellant system feeds the engine, which generates thrust. The body and fins keep the rocket stable while the payload carries out its mission. Section 5. Building your own rocket, a step-by-step guide. Now that we understand the basics of rocket science, let's get our hands dirty and build a simple model rocket. Don't worry, it's easier than you might think. Here's what you'll need. A solid fuel engine. This is the heart of your model rocket, providing the thrust for liftoff. A lightweight rocket body. A cardboard tube will do the trick, providing structure and housing the engine. Fins. These help stabilize your rocket in flight and can be made from cardboard or balsa wood. A parachute system. This ensures a safe and gentle landing for your rocket after its flight. A launch pad and ignition system. A stable launch pad and a safe ignition system are essential for a successful launch. Once you have your materials, follow these steps. 1. Assemble the rocket body. Attach the fins to the body tube using glue or tape. Ensure they are evenly spaced for stability. 2. Insert the engine. Carefully slide the solid fuel engine into the bottom of the rocket body. 3. Pack the parachute. Gently fold the parachute and place it inside the rocket body above the engine. 4. Prepare for launch. Secure your rocket to the launch pad and connect the ignition system. 5. Countdown and launch. With a clear launch area, begin your countdown and ignite the engine. Section 6. Ready for launch, igniting the dream. Watching your model rocket soar into the sky is an exhilarating experience. As the engine ignites, a burst of flame and smoke propels your creation upward. The fins guide its path, keeping it stable as it climbs higher and higher. The feeling is even more incredible knowing that you built this rocket with your own hands. But the excitement doesn't end there. As the engine burns out, the parachute deploys, slowing the rocket's descent. It gently floats back down to Earth, ready for another adventure. Each launch is a chance to learn, experiment, and refine your rocket-building skills. Building and launching model rockets is a fun and educational hobby. It teaches you about aerodynamics, physics, and the power of engineering. Who knows, it might even spark a lifelong passion for space exploration. Section 7. Model rockets versus space explorers. While our model rockets are a great introduction to the world of rocketry, they are just a small taste of the real deal. The rockets used by NASA and other space agencies to explore our solar system are far more complex and powerful. One significant difference is the type of fuel used. Model rockets typically use solid fuel engines, while real rockets often use liquid fuels like liquid hydrogen and liquid oxygen. These liquid fuels provide much more energy, allowing rockets to reach incredible speeds and travel vast distances. Another difference is the use of stages. Real rockets are often multi-staged, meaning they have multiple sections, each with its own engine and propellant tanks. As each stage expends its fuel, it detaches and falls back to Earth, allowing the remaining stages to accelerate faster and reach even greater heights. Despite their differences, both model rockets and real rockets operate on the same fundamental principles of physics. They both rely on Newton's third law of motion and the power of thrust to overcome gravity and achieve flight. Section 8. Reaching for the stars. The future of rocketry. Rocket science is constantly evolving. Engineers and scientists are always working on new technologies and designs to improve the efficiency, power, and capabilities of rockets. From reusable rockets that can launch and land vertically to ion propulsion systems that can propel spacecraft for years on end, the future of rocketry is filled with exciting possibilities. These advancements in rocket technology will enable us to explore our solar system and beyond in greater detail than ever before. We'll be able to send humans to Mars, establish lunar bases, and perhaps even venture to the outer planets and beyond. But the impact of rocketry extends far beyond space exploration. Satellites launched into orbit by rockets provide us with global communication, navigation, and weather forecasting. They help us understand our planet better and address critical issues like climate change. Section 9. Ignite your passion for space. From the earliest fireworks to the mighty rockets that carry our dreams into space, rocketry has always captivated the human imagination. It's a field that pushes the boundaries of science, engineering, and human ingenuity. If you've ever looked up at the night sky and felt a sense of wonder, if you've ever dreamed of exploring the cosmos, then rocketry might be the field for you. There are countless opportunities to get involved, from building and launching model rockets to pursuing a career in aerospace engineering. So, what are you waiting for? Ignite your passion for space, reach for the stars, and who knows, maybe one day, you'll be the one designing the rockets that will take us to Mars and beyond.